After more than 30 years of research, a team from the universities of Bayreuth and Edinburgh has finally succeeded in producing a very special material. It is said to be harder than diamond and even damage the diamond press in the laboratory during the hardness test. But it also starts to glow when energy is applied to it, and it could even be a pretty good superconductor. Find out what this crazy material is all about, how it was made and what it will be used for. And with that, welcome to the German Science Guy. I'm Dr. Jakob Beautemps, and in Germany we say Los geht's. Carbon nitrides have been known to researchers since 1989, at least in theory. Carbon nitrides are compounds of carbon and nitrogen that have very special physical properties. However, their most striking property is their extreme hardness. The 1989 study predicted that they could even be harder than diamond. More than 30 years later, the breakthrough has finally come. The international research group has been able to produce 4 different variations of it. But there's a second thing that is quite impressive. These materials were produced at an extremely high pressure of over 100 gigapascals. To put this into perspective, at the deepest point of the ocean, the pressure is only around 0.1 gigapascals. 100 gigapascals would be the pressure exerted by an object weighing 10 million tons on an area of 1 square meter. This means that the carbon nitrides are produced under extremely high pressure, but they remain stable even under normal environmental conditions. And that is not only rare for such materials, but according to the research group, it is a unique case. This is what makes them so interesting for practical applications. But let's first take a look at what makes a material hard in the first place and how the carbon nitrides were produced. The hardness of a material is of course determined by its molecular composition. One very important factor here is the strength of the bonds between the atoms. There are different types of bonds, but in general, the stronger or more energetic a bond is, the more energy is required to mechanically break the bond. The distance between the atoms is also a very important indicator because the closer they are to each other, the stronger the binding forces and the more stable the material. However, the arrangement of the atoms in a crystal structure is also a very important factor, because it can also be more or less stable depending on how symmetrically the atoms are arranged within it. Diamonds are the hardest naturally occurring material. They consist mainly of pure carbon in crystallized form. The carbon is held together by very strong covalent bonds. Each carbon atom is connected to 4 other carbon atoms. This creates a tetrahedron as a stable building block. If you look at the crystal lattice of a diamond, it resembles a cube-like structure. It is not a simple cube, but a symmetrical and fairly dense structure. This arrangement and the strong bonds make diamonds so hard and difficult to dent or damage. Okay, you can see I'm really excited about this topic, but as always it's very important for me that it is scientific and that I'm transparent with my sources. So in every of my videos you find the sources here in the corner, and then in the video description you find the link to the sources. So if you want to check, do this, and I'm very eager to improve myself. So if you have any feedback for me, please do this. And by the way, if you want to support this channel, you can easily subscribe and activate the bell. It costs you no money and it helps me really much. So thank you very much, but let's continue with the material because it's crazy. However, there are other extremely stable materials that consist of pure carbon. One example you probably know is graphene. Similar to diamonds, the carbon atoms in graphene are also arranged in a fairly symmetrical pattern. However, in this case there's only a 2-dimensional lattice of carbon atoms. Several layers of graphene stacked on each other are called graphite. Unfortunately, the bonds between the layers are very weak. In fact, pencil leads are made of graphite and they tend to break easily. That's why pencils aren't the hardest material in the world, even though they contain super hard graphene. There's also carbide and is said to be 40 times as stable as diamond. However, it consists of only a single chain of carbon atoms, and it has to be shielded by carbon nanotubes because it is so reactive. It's also super exciting, but carbon nitrides are currently a more promising option for replacing diamonds. As the name suggests, carbon nitrides also consist of carbon, but nitrogen is added to this. The nitrogen supports the stability of the crystal lattice. The basic building block of the crystal structure are actually tetrahedrons again. In this case, 1 carbon atom is connected to 4 nitrogen atoms. According to the original study from 1989, these tetrahedrons have a particularly strong binding force, as it was calculated that the bond length between carbon and nitrogen is shorter than between the carbon atoms in diamond. They actually assume that carbon nitrides can be harder than diamond. We will come back to whether this is true and it has been proven now, but first let's take a look at how the material was produced. To actually produce the nitrogen nitrides, they used two things: extreme pressure and heat. They filled various precursors made of carbon and nitrogen into a diamond anvil cell and then subjected the whole thing to a pressure of 70 to 135 gigapascals. A total of 6 diamond anvil cells were filled using different combinations of carbon and nitrogen in some cases. In addition to this extreme pressure, the diamond anvil cells were heated to over 2000 degrees Celsius by a laser. Here you can see what 3 of the 6 samples looked like before, during and after heating. In total, the research group produced 4 variants of carbon nitrides. They then tested the internal structure. The crystal lattice differs between the 4 materials, but the basic building blocks are always these tetrahedrons of carbon atoms with 4 single bonds and nitrogen atoms with 3 single bonds. The crystal structure of the first material is very dense and symmetrical. And it was precisely this material that they used for their endurance test. To do this, they placed it back in the diamond press and subjected it to extremely high pressure again. This test was quite successful as it damaged the diamond press. In this photo you can see the areas where the surface of the diamond was indented. The press release from the University of Bayreuth in Germany even refers to ultra incompressibility. This means that even under extremely high pressure, the volume of the material remains virtually the same because it cannot be compressed. But are carbon nitrides really harder than diamond in practice? We asked the University of Bayreuth about this, and the answer is quite interesting because it is no. Carbon nitrides come close in practical tests but do not exceed the 440 gigapascal that diamonds can withstand. This means that the 1989 prediction has not really been confirmed in practical tests. Nevertheless, we have a new ultra-hard material that can compete with diamonds in terms of application. Of course, the manufacturing process still needs to be optimized, but if we could soon replace diamonds with a cheaper alternative in industry, it would be a real game changer. However, hardness is by no means the only special property of carbon nitrides. Just like diamonds, they can also be used as insulators because their large band gap means that they hardly conduct any electricity under normal conditions. Unlike diamonds, however, they can be enriched much more easily with other substances to change their properties and, for example, improve their conductivity. At the same time, they have a high energy density and they are piezoelectric. This means that when bent, they release energy in the form of electrons. According to the group, the values here are 2 to 4 times higher than for quartz, which is used as a standard for piezoelectricity. In addition, they begin to glow when energy is applied to them with a laser, which is called photoluminescence, and this property could be exciting for photonics research. The research team even believes that carbon nitrides could be good superconductors, meaning they could conduct electricity without resistance under certain conditions. Of course, research still needs to be done on all of these applications, but as always, we will keep you updated when there are any news on this channel, so don't forget to subscribe and activate the bell. So let's come to a conclusion. All of this means that the material's special properties make it interesting for a wide range of research areas and applications. And it's also really crazy that after more than 30 years we finally managed to produce these materials. Of course, the manufacturing process still needs to be optimized, but overall, this sounds like a huge breakthrough to me that could revolutionize several areas. And I love it when people achieve such breakthroughs after a long time and drive innovation forward. I'm curious to hear your thoughts on this video, and if you want to know more about material science, here is another video of my channel, so feel free to watch it. And thank you very much for watching the video today. I say goodbye, or as we say in Germany, auf Wiedersehen.